Hello everyone and welcome to 11.0b, talking more about perimeter and area. Today we're going to focus first on the area of a regular polygon. So we've now done area of the kind of basic shapes, our squares and our triangles and those types of shapes. Today we want to talk about how to find the area of a regular polygon, so something that has 5 or more sides. So a couple things that we need to talk about. Firstly, we're going to talk about some vocabulary here. So the distance from the center of a polygon here to the side of the polygon here is called the apothem or apothem, depending on how your teacher says it. And the next part says the blank of a regular polygon is the distance from the center to the vertex. This is a familiar word. This is our radius. So our polygons are going to have radii, just like circles. So in labeling this picture over here, this is our apothem going straight to the side. And then from here to the vertex, again, is called the radius. You can see that we're forming a little right triangle inside that shape. And that's going to be really important to us in just a second. The formula to find the area of any regular polygon is just area equals 1/2 the apothem times the perimeter of the figure. Apothem times the perimeter, and then divide it by 2. So let's take a look at example 1. It says, find the area of each figure and then round to the nearest hundredths if necessary. So the first thing I'm going to need to do here is I'm going to need to figure out what one of these measurements is. I don't have enough information here to solve this problem. I have the apothem, right? I can see that A equals 5, so I'm partway there. But I also need to know P, the perimeter. So here's what we're going to do. We're going to connect this point to the vertex to create the radius of the shape, the polygon. And now I can see that I have a nice little right triangle going on here. And we're going to bring back some stuff from a couple chapters ago. We're going to do some trigonometry. That's right. We got some trigonometry going on here. So here's what I want you to think about. If I were to take, this is a hexagon, right? We got 6 sides. If I were to take that hexagon and from this center draw an angle going out here, well, look kind of up in this picture. You can see that really this is just a shape that's kind of like a circle, but not a circle anymore, right? So we can still think about our properties of a circle. We know that all around the inside there should be 360 degrees. And since it says that this is it, well, it doesn't say it, but this is a regular shape. I think all of these are regular shapes. They have to be. Oh, yeah, because we're talking about regular polygons. Haha, it's right there. So all the sides are equal. So I know that if I take the 360 that makes up the total round shape and divide that by the 1, 2, 3, 4, 5, 6 sides, I'd get 60 degrees. So what I know is this angle right here is 60, because then I have 60 here, 60 to this side, 60 to this side, 60, 60, 60, and that would give me 360. But here I'm cutting it up and just doing half of that. So what I know is that this is a 30-degree angle. So I'm going to draw that triangle a little bit bigger over here. I have a 30-degree angle right here, and this is 5. Well, you're going to use your special right triangles or your trigonometry here. Special right triangles would be better as long as you've memorized them, but you could use trigonometry if you got totally stuck. But basically, we know that this is going to have to be a 30, 60, 90 triangle. And what I know is that if this side is my smallest angle, then that's going to be half of the biggest side. Meaning this represents my L square root of 3 side. So I know that L square root of 3 is equal to 5. So I can divide both sides by the square root of 3. And that's going to give me L is equal to 5 over the square root of 3, but I don't want square root of 3 in the denominator. So let's multiply by square root of 3 on the top and the bottom. And I get 5 square roots of 3 over 3. So what that tells me is that right here, from here to here, is 5 square roots of 3 over 3, which means all the way across is going to be 10 square roots of 3 over 3. And then I can go around and add all of that up to get the perimeter, right? 1, 2, 3, 4, 5, 6 of those. So I'm going to get 6 multiplied by 10 square roots of 3 over 3. Well, that's just going to be 60 square roots of 3 over 3. And we can do a little simplifying there. 60 divided by 3 is going to give me 20, so I have 20 square roots of 3. And just like that, we have all the info we need. We have the apothem, we have the perimeter, and now we can go ahead and solve using our 1/2 AP formula. So area equals 1/2 times the apothem times the perimeter, 20 square roots of 3. And I can multiply this together. 5 times 20 is 100 square roots of 3. And then half of 100 is 50 square roots of 3. And we were using meters, so it's meters squared for area. Taking a look at the next one, in this problem they gave me the side. So since they gave me the side, finding the perimeter is going to be easy this time. Perimeter is going to be equal to 1, 2, 3, 4, 5, 6, 7. There's 8 sides, so 14 multiplied by my 8. And that's going to give me 112 meters. So now all I need to address is what the apothem is in this problem. So again, we're just going to construct a little triangle right here to help us out. There's my apothem that we need to find. Here's the radius. And now since we got 8 sides going on, let's take 360 and divide it into 8 again. And I get 45. Well, 45 then is going to represent the whole thing, right? You want to be careful because basically when I did this and divided by 8, 45 represents this angle going all the way across, which means I have to break it in half, right? So when I take 45 and divide it by 2, that means this angle right here is 22.5. So what's going to happen here, let me bring that triangle out. I'm going to move it upward a little bit so it makes a little bit more sense. Here's my 22.5. When I came up here and separated this, 14.5 is 7. Well, to find the apothem, I can't use a special right triangle, which if you saw that 45 and immediately tried, you would have made a mistake. So that's a really easy mistake to make. I need to know what this side is, x. So I'm going to have to use my trig properties. I can see that the 7 is opposite of my 22.5, and x is adjacent, so I know that that represents a tangent function. The tangent of 22.5 equals the opposite side 7 over the adjacent side x, which means overall that's going to be a division problem. 7 divided by the tangent of 22.5 would equal x. So in my calculator, I'm going to type 7 divided by, we're going to type 22.5 first, take the tangent, press equals. I get 16.89, so we can round that to 16.9. And that's going to represent, like we said, the apothem. So now again, we can do our formula. Area equals 1/2 the apothem, which is 16.9, times the perimeter, which is 112. 16.9 times 112 divided by 2, and I get 946.4, and it was meters, so meters squared. All right, and in our last example, this one they gave me a radius. So in this case, again, we're gonna need to draw the apothem that I'm looking for. So in this case, I have nothing I need. I don't have the apothem. I don't have the perimeter. I gotta find all the things. So we're gonna start by setting up our problem. So this is 5 sides, so let's take 360 and divide it by 5. So I can see that each big angle is 72. Divide it by 2 to split it into just that one little half. And I get 36 here. So let's start by finding the apothem. So I've got this right triangle, 36 degrees here, 19 meters here, and I need to find this side. So I've got my adjacent side, and across from the 90, that's my hypotenuse side. So it looks like this is going to be a cosine function. So the cosine of 36 degrees equals the adjacent x over the hypotenuse 19. So that looks like a multiplication problem. Take the cosine of 36 and multiply it by 19. I get 15.37. Now again, remember this represents the apothem of my figure. So let's go ahead and change it from x equals to just a equals. And now I need to find the length of this side so that I can go around and find the perimeter. So I can maybe call this y. I'm going to do the exact same thing, but this time y is opposite and I have the hypotenuse still. So I'm going to use sine of 36 equals the opposite y over the hypotenuse 19. And again, we're just going to multiply. Take the sine of 36, multiply it by 19, and we get 11.6167, so 11.17. Again, this is just half of this side. So I know that I'm going to need to put it here, 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 10 spots, right? So you could multiply it by 10. And we get 111.679, so 68. So the perimeter is 111.68. And we have now our two parts. So A equals 1/2 the apothem, 15.37, times the perimeter, 111.68. 111.68 divided by 2. And I get 858.26 for my area. So that covers the first part of this. The second part of what we needed to talk about on these notes in 11.0 is composite figures. So a composite figure is if I take more than one figure and put it together. So it's a figure that can be broken up into multiple figures, or into that are basic figures, into, we're going to call it multiple parts that are basic plane figures like triangles, parallelograms, trapezoids, rectangles, circles, etc. To find the area of a composite figure, you're going to break up the regions and then find each area. So separate the regions and then find the area of each individual region, and then you're going to add all of them together at the end. So taking a look at this first problem, you can see example 1. We've got to find the area of this figure, and it looks like they've already separated it for us. It looks like right here in the middle, I've got a parallelogram. And then on the outside, I've got two semicircles. So together they make one circle. So I need to find the area of the parallelogram and find the area of the circle. So I'm going to start with the parallelogram. Parallelogram is easy. Parallelogram is just area equals base times height. Well, the base in this case is 6. The height is 5. So we find that the area equals 30. And then we can address the circle. Again, you don't have to do each semicircle individually, because I know if I pick them both up and put them together, I'd have one full circle. So we're just going to find the area of the full circle. So area equals pi r squared. And in this, you can see that the circle goes all the way across here, meaning the diameter is 6. So the radius is 3. So area equals pi 3 squared. It says round to the nearest hundredth, so we're gonna put this in our calculator. 3 squared is 9 times pi, and we're gonna round that to the nearest hundredth, so 28.27, doesn't round up. Now that you've got both the area of the parallelogram and the two semicircles put together into one circle, now we can add it together. 30 plus 28.27, that's gonna give me 58.27, and it was in inches, so we can add our units now. Inches squared, since it's area, and that's my final answer. I was off the screen, I'm sorry. Leave it there for a sec so you can catch up. 58.27 inches squared. All right, taking a journey to the back. We're almost done. 2 more examples. Example 2 says find the area of the figure. We can see that we got a few shapes going on here. It looks like we got some sort of square going on here. Definitely a square, because they've got this side marked and this side marked as congruent, which means this side and this side are also congruent. I've got a triangle and I've got a trapezoid. So we got a lot to do here, a lot of things to look at. We're gonna start over here by looking at this triangle. In order to find the area of the triangle, I need to do 1/2 base times height. you can see that the triangle is kind of sideways, right? This is how it should look. So my height is 9.6. The problem is I don't know how big the base is, but it is a right triangle. So I can do Pythagorean theorem. A squared plus B squared equals C squared. And I can figure out what that missing part is. So let's just do that over here real quick. A squared plus B squared equals C squared. I know that 12 has to be C because it's the hypotenuse. 9.6 can be A. And we just need to solve for B. So overall, I'm going to take 12 squared, and I'm going to subtract 9.6 squared from it. So I get that B squared equals 51.84, and I can square root it, and I get that B equals 7.2. So I know that from here to here is 7.2, which means the whole thing is 7.2 times 2, so 14.4. So all the way across is 14.4. So now I can find the area of that triangle. 1/2 times the base, 14.4, times the height, 9.6. Times 9.6, divided by 2 for the 1/2, and I get 69.12. So we will come back to that. Now I can look over at the square, and actually doing the triangle helped make the square easier because I didn't actually know how long the square was. But now that I know that this side's 14.4, since all four sides are equal, I know that this side's also 14.4. So now I can do the area of my square. Squares are pretty easy, right? Squares are just area equals base times height. So I'm gonna do area equals 14.4 times 14.4, or 14.4 squared. 14.4 squared, 207.36. And now we're on to the last part, that little trapezoid on the bottom. So that trapezoid on the bottom, we now know the base is 14.4, given from the square and that triangle up there, and we know the other base is 10, but we also need to know the height of the trapezoid. We can't solve trapezoids without height because the formula is area equals 1/2 base 1 plus base 2 times the height. So I need to know the height. Well, that's going to be pretty easy to find because I know that the whole thing is 25.4. But I know that this is taking up 14.4 of it. So if I take 25.4 and subtract 14.4, it looks like that's going to go, I'm going to have 11. So it looks like 11 has to be this length right here, which represents the height of our trapezoid. 11, 14.4, together that makes the 25.4. So now I got the stuff I need. Area equals 1/2. Base 1 is 14.4, plus base 2, which is 10, times the height of 11. So I'm going to work from the parentheses first. 14.4 plus 10, divided by 2 for the 1/2, and then times 11. And I get 134.2. And last step, just add our three areas together for the three figures we have. So 69.12, 134.2, and 207.36. Add that all up. 69.12 plus 69.12 plus 134.2 plus 207.36 equals 410.68. And our units, in this case, were meters, so we've got meters squared. All right, bringing it in for the last example in these notes. Example 3, this one looks a little bit different. It says find the area of the shaded region to the nearest hundredths, and they have an unshaded part. So instead of adding in this problem, we have to subtract the part that we don't need. So you can see here we've got a trapezoid going with a little semicircle cut out of it. So to find the trapezoid, we're going to use that formula we just used up top. Area equals 1/2 base 1 plus base 2 times the height. I have base 1, I have base 2. If you jumped here and said that was the height, you'd get it wrong. We got to find the height here again. So I'm going to drop a perpendicular line straight down. That would represent the height. And now I've got a little right triangle up front. since this is 17, given from up here, and the whole thing's 37, I know that if I take 37 and subtract 17 and get 20, that this part has to be 20 so that this part can be 17, and then 20 and 17 make the full 37. So now I've got a little right triangle here that I can actually do Pythagorean theorem with. A squared plus b squared equals c squared. In this case, the only thing I care about is the fact that c has to be the hypotenuse. So we can make a is 20 squared. We're solving for b squared, and the 25 is the hypotenuse, so that has to be c. So I'll subtract 20 squared from both sides. B squared equals 25 squared minus 20 squared. So 25 squared minus 20 squared, and I get 225. Square root both sides, and you get 15. So now I know that height is 15, so now I have the important things I need. Base 1 is the 17 on top. Base 2 is the full 37 on the bottom, and the height is 15. So 1/2, that's going to be 17 plus 37 is going to be 54 times 15. Let's see, so 54 divided by 2 times 15. I get area equals 405. So that's the area of this full trapezoid, but again, we have that semicircle being cut out. So I need to get rid of this. Well, since the height here is 15, we know that the diameter of the circle, or the semicircle, is also 15. So area equals pi r squared, but since it's only half of a circle, we're gonna have to divide it by 2 at the end. So pi times, 15 is the radius, is not the radius, it's the diameter, right? So we divide it by 2 to get the radius. So 7.5 squared divided by 2. Let's go ahead and put that in. So 7.5 squared is 56.25. Times that by pi, and then divided by 2. I get that the area equals 88.357, so 36. Again, we're taking that unshaded area out. So now that we have our area of our unshaded area, we're going to do a subtraction problem. 405 minus the 88.36. 88.36, and I get 316.64. 316.64, and this was in inches. Ooh, I'm way off the paper. Inches. I apologize for that. Subtract that, we get 316.64 inches squared, and that will be our final answer, and that brings us to the end of those notes. As always, if you have any questions, please come talk to us, your teachers, and we will help you out. Have a great day, everybody.